So when we go through and rationalize fraction with complex numbers, we do this exactly the same way as if we had a radical in the denominator. So we'll go ahead and start off with something simple like 1 over the square root of -7. So first by turning that into 1 over I times the square root of 7. And what I do is I multiply both the numerator and the denominator by the same thing, which is I square root of 7 over I square root of 7. And that gives us I square root of 7 in the numerator. And in the denominator, I times I is I squared, which turns into -1 times the square root of 49. So that is I square root of 7 over 7, -7. And you can just put that negative in front if you want to. Both of those would be the same answer. Now, a little word of warning about this question. A lot of times I will see this error. There is a second way I can go ahead and do this. And I want to show you this because when I see this, I see a lot of mistakes with this piece. You can multiply it by the square root of -7 over the square root of -7, which equals I square root of 7 in the numerator. But be very careful in the denominator, because if I multiply the square root of -7 times the square root of 7, it does not equal -7. You must first change those to imaginary numbers. That's I square root of 7 times I square root of 7, which is I squared, and the square root of 49, and that is where you get I square root of 7 over negative square root of 7, and that answer of course matches up. But just be very, very careful that you don't make an error in that denominator when you're working on and doing that problem that second way. Okay, let's also go back to how we're going to see this if we're using the quadratic equation. And we end up getting something that looks like this. Let's say you have a problem that looks like -8 plus the square root of -12 over 4i. Again, the first thing you always need to do is turn anything that's in the radical back into imaginary numbers. So that gives us -8 plus I, the square root of 12, can be broken down into 4 times 3 all over 4i, and that simplifies to be 8 plus, I take the square root of 4, which becomes a 2i square root of 3 all over 4i. Now, this is not going to be your final answer, and the reason is the same way that you have and cannot leave a square root in the denominator, you must rationalize that imaginary number. So I have to multiply the numerator and the denominator here by I over I. I distribute the I in the numerator, and I'm left with -8i plus 2i squared square root of 3 all over 4i squared. So the next thing I'm going to want to do is with wherever I saw that I squared, I'm going to replace I squared with -1. And now I'm left with -8i plus 2 square root of 3 all over -4. But beware, all complex numbers must be written in this form a plus bi, where the real portion is first, then the imaginary portion. So I need to go ahead and break this up. And I'm going to rewrite this as negative 8i over negative 4 plus 2 square root of 3 over negative 4, which when I reduce this, it becomes 2i minus 1/2 square root of 3. But again, that's not the correct order. The real portion, this portion must be written first. So that's going to be written as the square root of 3 over 2 plus 2i. So that would be your final answer for that question. All right, so now we have something that is definitely a little bit more complex, because if I go ahead and look at the denominator, I have 2 portions in the denominator. So before I rationalize, I do want to go ahead and simplify the numerator a bit. First thing, again, always break that up. So that's going to be negative 6 plus, that's going to become I square root of 9 times 2 all over 2 plus 3i, which when I take that 9 out, it's going to leave me as negative 6 plus 3i square root of 2 all over 2 plus 3i. Now again, I can't leave that because I have an imaginary number in the denominator. So I multiply by what is called the conjugate. So I multiply the numerator and the denominator by 2 minus 3i. So when I say the word conjugate, what I mean is that what I have in the denominator, I multiply by the exact same thing. The only difference is, notice that the sign goes from 2 plus 3i to 2 minus 3i. Now, yes, you do have to FOIL both of those out. So foiling this out in the numerator gives us negative 6 times 2, which is negative 12. Then I have negative 6 times negative 3i, which gives me a positive 18i. The next one is negative 3i square root of 2 times 2. What is outside gets multiplied with other pieces that are on the outside, so that leaves me with plus 6i square root of 2. And finally, it is 3i square root of 2 times negative 3i. The I is on the outside, I multiply those together. That ends up giving me a negative 9i squared, square root of 2. I'm going to do this out the long way in the denominator. Just this once, you don't always have to do this. Remember that the reason for doing the conjugate is it's the difference of 2 squares. But if I were to multiply this out the long way, it would give me 2 times 2, which is 4. Then 2 times negative 3i, which is my negative 6i. 3i times 2, which is my positive 6i. These will always cancel out. That's why we multiply by the conjugate. And then finally, positive 3i times negative 3i is negative 9i squared. So we're going to take both of those I squareds and turn them into negative 1. And then simplify. So I have negative 12 plus 18i plus 6i square root of 2. And that is all going to be over 4. That turns into a positive 9 because it's a negative 9 times a negative 1. So that's going to turn that into a 13. To write that as a real portion, and then my imaginary portion, it would just be negative 12 over 13 plus 18i plus 6i square root of 2. plus 9 square root of 2.